my face, but I can't. You'd probably rather see this. So anyway, Voltaire, just basically getting ROS 2 set up to run some robot we're working on. I want to run a simulator on NVIDIA Isaac, but currently, well, for a lot of reasons, there's a lot of tie-ins to the NVIDIA Isaac that are in ROS 1, as well as the one of the things that I'm planning on using. The simulator has ROS 1 tie-ins, not ROS 2 yet, probably coming quick. But in the meantime, I'm like, well, it's probably good to know ROS 1, how ROS 1 can send stuff to ROS 2 or vice versa, to be able to communicate between those two, but also in case there's packages that I'd want to use in ROS 1. So I figured, well, I got to figure out this ROS 1 bridge thing. And believe it or not, it's not that bad. I did set up, so this is in a virtual machine, which is some other fun stuff I was messing around with. But so this is, my laptop is running Ubuntu 18 booted. But I wanted to do some stuff in Noetic and Foxy, so I installed the virtual machine for Ubuntu 20. Not that it's required, but it just kind of worked itself out. And so I have Noetic and Foxy installed on here, and Foxy is ROS 2, and Noetic is the latest and last ROS 1. The biggest challenge, I think, is I ended up having to go back through. You know how to do ROS 1 install. There's like that 2-line install or single line install. There's a bunch of options out there. But then you have to switch to your ROS 2 install. And it has to, the part I forgot along the way is, and I'll include the link in here later, you have to make sure you include the sources for ROS 1 and ROS 2 for the ROS 1, so the ROS 2 can find it when you do the build. I don't want to take you through too much of that, but basically, in one, and if I follow along, I'll give you the ROS run bridge link. Hold on one second, let me bring that up. Working on a video. ROS 1 chat. All right, so if you want to follow along and point at my errors, that's totally cool. Come on in. We all know that I like to be on the hot seat with everyone watching. Remember that day? That was amazing. All right, so I did some weird stuff first. Can you guys see all the tabs, right? All my windows? Okay.
Yes.
Okay, cool. All right, so like I say, just at the bottom of my bash script, I just put in the aliases. So for me, alias Foxy is equal to the location, because I just got tired of typing it. It wasn't a big deal. It just was kind of a pain. And then, someone showed me this magic trick, and it works. So, and I did the same for ROS 1, which becomes important because as we're setting up this bridge to work, you need that. Sorry, I'm actually switching a video on the back here, or a screen. All right, so if we walk through the setup, basically in shell 1, you're just gonna reference ROS 1, which for me on this one is, you can do ROS version -d. I got Noetic running in here, so which is kind of nice to see it work with, I've done it on Melodic and Noetic. And then I run my ROS core here. This is where he'll start. Hopefully he doesn't yell at me. All right, and then you come over into your B terminal, and this is gonna be a combo of ROS 1 and ROS 2. And that's just so it knows how to communicate between it. So we'll do ROS 1 first. Oh, I did Foxy first. Whoops. I don't know if that matters. Of course it does. Watch this. Watch it mess up. And then basically, literally, you just reference the source for ROS 1. And then on the next one, you run Foxy, which is your ROS 2. And then make sure you have your master URI. Oh, I bet you I messed this up earlier. I asked a question in chat, and I bet I just ruined it. All right, let's see if this works. Let's see how we go. All right, so you're just making sure that the ROS master URI is right, and then you run a ROS 2 node, ROS 1 bridge, and then it's just a dynamic bridge, and it's kind of cool. I did it a few different ways today. I'm only going to show the one. I did try to do like the camera, but of course my virtual machine and my camera, I couldn't get it to work. So I'm just going to do the talker and listener. So now we have the bridge running, right? And if you notice, when I go in here, I'm going to open up 2 more terminals. And this one's going to be ROS 1. And in here, I'm just going to do ROS 1. And I already installed the ROS Pi tutorials, and this guy's the talker, right? Just like me, he's the talker. And then we come over here. I know, not groundbreaking, I am aware, but it's pretty cool. And then Ross, Foxy on this one. And so Ross 1 is the talker, right? And then Ross 2, I'm going to make it the listener. And it's difference between the Python versus the CPP, which they always want to show off as cool. And then magic happens. Look at that. Isn't that cool? And so here in the Ross bridge, it shows you that they are passing. And I can keep doing this back and forth. And as long as that Ross bridge is running, it knows which direction to go. So if I wanted to send the other direction from Ross 2 to Ross 1, it would do the same thing.
Can you,
if you look, go ahead.
Can you show us the RQT graph? Will they look different based on Ross 1 versus Ross 2?
Good question.
It might be Ross run. Oh, you got it. Okay.
That's it on this guy. Interesting.
So your Ross bridge is basically your ultimate sync.
Correct.
Okay.
It knows how
That's
to
cool.
make it go back and forth, which is kind of nice. And I did have some LiDAR data I wanted to show through this, but I ran out of time, work and stuff. Anyway, so I know it's not groundbreaking, but it is really cool because as we transition to ROS 2, there's going to be reasons why ROS 1 makes sense. And I watched a video from Mike Ferguson. Thank you for posting that link the other day for the Homebrew Makers Club the other day. And then I watched, Mike Ferguson talk towards the end and talked about a lot of different things. And this one came up in there too, I think. So that's it. Any questions?
That is pretty cool, Walter.
I think I don't know. And Walter did it, so it's Walter proof at this point.
Hey, look at that.
Yeah, I was going to try to mess around with this. This is actually running on my host machine. It's just laser data. I mean, it's just whatever. Everyone's got laser data. That's for a future day. All right. Thanks, Matt.
That's pretty sweet, Walter. So that ROS 1 and ROS 2 are running on the same virtual machine?
Currently they are. And I think I was earlier, I thought I worked earlier to get it working on the host, but I didn't. I was working on the host, but I don't remember if I had it working there. But you could have it running wherever, I think. I wonder if I can try that in the background while someone else talks, maybe. Let me see. Oh, my skills.
So you had, so you started ROS 1 and that was the talker. And then you went over to ROS 2 with a CPP and did the listener.
Correct. And then the bridge just knew which direction to send. And it converts. So everything goes in through the bridge, which is pretty nice. I'm going to try it over here, actually. But I'm going to do this in the background. Sorry.
It's pretty interesting that the RQT graph inside of ROS 1 doesn't see the nodes running in ROS 2. So it's just like, it's just passing the messages from the topics.
You could probably run a version of RQT graph under ROS 2 and see something equivalent on the other side. But I don't know what it's called there.
What is that? What is that command? It's ROS.
Well, basically do the same thing you just did, but do it under your Foxy. And I don't know if it's going to be the same command, but you can try it.
We'll find out right now. Wally G Funk on the hot seat.
This is that shows you what's happening on the other side of your ROS 2 bridge, or the other side of ROS bridge.
Why isn't that zooming in? Can you guys see that pretty good? It's really small.
I've had trouble with RQT tools on ROS 2.
If you have a mouse, try the scroll wheel. That'll zoom in.
Thank you. Thank you. That worked. So let's compare them. So chatter.
Something happened. It got really small.
Both of them did? How about now?
A little bit better, but I don't know if you want to do like split screen, half.
Yeah, I will.
That's interesting. So like on the ROS2 side, the RQT graph shows you everything running in ROS2.
Huh.
But it is showing you the listener.
So it looks like you really want to be using the ROS2 RQT graph because it shows you everything.
Well, it's missing the talker, I think. It's missing the node that's running on ROS1.
Each side is showing you what's happening under that complete instance. So under Foxy, it's showing you everything is happening there, and Ross Bridge just magically talks to the other side, and then ROS1 just has chatter, which is the talker, and it talks to Ross Bridge. So the one under ROS1 shows you everything under ROS1, and one under ROS2 shows you everything under ROS2, and they just magically connect through that Ross Bridge.
Yeah.
I love that we're talking robotics and you use the word magic. That makes my day. It's true. Very true. So it's cool. I think there's more investigation. You guys bring me up some questions that I have, like how do I then know, only if, like you're saying, if Jeff just used the RQT for that version. I do wonder. The topics are between the two of them. Woo.
ROS2 topic list? ROS2 space topic list?
Seriously?
Space list, yeah.
Duh. Interesting. Parameter events. Not related, I guess. Anyway, cool. All right, that's all the joy I have for today.
Okay, so I know a little like, what about other things like if you wanted to set, like where does the parameter server work, and can you set a parameter from or get a parameter from ROS1 to ROS2?
That is, what is the dynamic? Just got that dynamic thing today. What is that called? The dynamic, is that ROS dynamic parameter thing? Dynamic reconfigure. You guys heard of that? It's ROS1. And is it just dynamic? Yeah, ROS. Okay, let me just see if I can get it to run. Did you say that, Matt? And I didn't listen to you?
No, I don't know. I haven't used it yet, so I didn't know if how that works. If the ROS bridge is just topics, or is it doing other things?
So it was my understanding that parameter server had been deprecated in ROS2.
Okay.
Is that not the case?
Good question.
I don't know, but like if you were in ROS2 and you wanted to get something off of ROS1 parameter server, will it let you do that?
You can do the.
No, I think I was wrong about that. I'm sorry. I'm spreading false information.
Everyone's going to believe you. Okay, that's interesting. Let me try. Just making it up. And they're a little different. Huh. ROS distro, ROS launch, host Ubuntu. Yeah, I don't. Am I in the right? Yeah, Ubuntu. Okay, yeah.
Still pretty cool.
Raj. Yeah, next week I'll be like cursing because it didn't work right. It's okay. All right, I relinquish my time to the floor. Am I still sharing?
Yep.
Oh, push the button. Stop. I'm gonna work on this in the background, by the way, to see if we can talk between them, just to see.
Well, I ordered some ADD converters today just because it spontaneously hit me that I could. Actually, I got an email from Adafruit saying, here, look at our wonderful products. When I looked at the page, they had one, and I looked on eBay and found them like at a third of the price, so I just ordered some. And the other thing was, I was talking about painting some parts of my robot. So now they've been laying around for 2 or 3 weeks. I bolted them back on last night. So we'll see if the paint sticks after I do that. I did sign up for that Ross virtual conference that's coming up. I thought, well, why didn't they offer me a t-shirt? And it said something about after you do, they'll send you a link later to order a t-shirt. So I guess I'll have to look into that when the time comes. That's all I can think of right at the moment.
Yeah, I went through that registration also, and I didn't see where they were grabbing t-shirt sizes or selling those. So maybe that'll come out later.
It said right in the registration, just a line said that after you register, we will send you a link to order t-shirts. So that's that. After I read back through a couple of times, I realized that that's why they didn't mention it, because they already told me up front that that's what they were going to do.
Very cool. Any other updates?
Anybody watch that Mike Ferguson presentation the other day that you linked to?
I didn't watch it, but I looked at the slides afterwards, and within a couple of weeks, they'll post it out on the website so I can go watch it there.
It was kind of funny because Mike Ferguson was at Willow Garage and a bunch of other places, and he's been at Fetch, and now he's got his own securities, and he's still like he knows ROS 1, but still having some challenges between the ROS 1 and ROS 2, which is kind of funny. And he showed off obviously what he was working on, which is really cool, but still alluded to the fact that there's some, even the people who know it, there's still some learning curve. But it was I don't know, for me it was hopeful because it would look like it was still it was still useful. How do you know where all your ROS cores are running?
Yeah.
Is there anything that tells you, please? Sorry.
What's your question?
I'll wait. Go, Matt.
That's all right. Which one's your ROS cores?
Well, how do you know how many ROS? I mean, you can only have one on one machine, right?
Right.
Share your screen again.
Oh, now you're going to make fun of me. All right, here we go.
So ROS 1 will have a ROS core, and I don't know how ROS 2 works. I think they said something about there's some mythical thing that runs. How did they put that?
The demon.
A demon that runs for ROS 2.
I don't want any demons. Yeah, no time for that. It's 2020. 1 second, I'm trying to find it. I think it's because of how I set up my network, right? Share my screen again. Select my window.
It's simply that ROS 1 needs one ROS core running per machine, and you've only got one machine running. So you should have one ROS core running for ROS 1. And for ROS 2, it's got the ROS 2 daemon, and I don't know how that works, but I assume you have one of those per machine also. And since they're both running on the same machine, you should have one ROS core and one ROS 2 daemon.
I think it's because, yeah, my ROS core is running on my virtual machine still. Okay. I can't, my computer froze, so I'm sorry, Matt.
No worries. It's, sometimes, have you heard them called daemons?
Yeah.
Demons.
I know what a
sounds better.
daemon is, and I know we exercise them. Just kidding, it's fun.
So did somebody have another picture they were putting up there?
That's in, yes, showing you there's a RTK GPS mounted on the tractor. Get to spend a lot of time working on mounting brackets. Get that wedged in there just right.
Is that tractor number 2?
Nope, that's
Number
the
3?
lawnmower. No, well, that's the one I'm not going to modify. This one's got to run.
Well, that one has to actually mow the yard.
Yeah, you got to keep one working. Can't tear into all of them at the same time, or you'll have a disaster.
Yeah.
Yep. But I've been using that to test localization.
Which sensor was that one?
It's the U-Blox F9P RTK unit, and then the RealSense 265 visual odometry sensor.
Is the U-Blox? Oh, sorry. Go ahead, Walter.
I was just going to ask, like, you're saying the T265 is the visual odometry because that's what you're using it for, or?
That's what the sensor's made for.
That's what it's for. Okay.
Is the U-Blox unit kind of like the de facto standard for RTK, or is it just what you have?
It's just been very nice. This is the Ardu Simple one, and that's F9P. It's hidden right there, but that's the GPS thing. But it's really good. $200 for 2.5 centimeter accuracy. All burning on a Raspberry Pi 3.
That's
and then
awesome.
The RealSense is out here, and then monocular camera. Yep. Watch out, Trimble. This one's going big time. Gonna
So
start
that
selling them
flat-
on Amazon.
That flat cable, that's a Raspberry Pi camera. Is that what you got hooked on there?
Yeah. I've been testing that with fiducials.
Any luck, or is that just the Ubiquity based one, or what?
Yeah, the Ubiquity one. You can do AR tags with the RealSense. I haven't done that yet, but I've just been using the Ubiquity fiducial package.
I guess in a real world setting, right? Like where you're outdoors, what are the cons of using AR tags? Or are AR tags, are they pretty robust to basically ground yourself and localize yourself?
That's a good question. The only con I've heard is you have to install them in the infrastructure, and a lot of times people don't want to do that. Other thing is maybe you got to get close to it to be able to see it.
So you need the AR tags placed at a reasonable enough density to where you're, your robot localizes itself based on that. And then I guess you have to be accurate when you're saying, hey, AR tag number 3 is at this coordinate. And I guess it's diminishing returns. You have to basically balance that. So, okay, I think I understand, pros and cons of using AR tags.
Which is funny because I saw in my visit to China and also in the US, they have these material handling robots that are probably, smaller than tabletop, enough to hold a package that would maneuver on top of some shelves, basically. So a robot arm would pick a thing off of a conveyor, load it on the top of this robot, and that's how these little guys literally maneuvered at like, I don't know what, super high rate of speed, zip, 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 zipping around, dropping the package into the right chute, and then going around, and all of that navigation, well, other than maybe some a little localization with odometry, they had no other sensors than the QR codes on the floor, which was kind of an interesting thing I didn't even think of before I saw that.
Yes, the advantage of that in the material handling sense, you're in a built environment where you could put the QR tags on the floor.
Yeah, no big deal. Right, paint them.
So Alan, did you get your localization working?
No, not yet. Let me share my screen though. So this is the question that I have that I'm trying to figure out. So if I run ROS topic info on TF, I have 5 publishers and about 7 subscribers, something like that. So I just listed out, I mean, this is what it looks like to me. I've got these publishers all going to the TF topic, and then all these guys are subscribing, pulling back out. And if I run if I echo on this TF topic, and this is the data, Jeff, that you were looking at the other day, if I switch over here, I put it into a pivot table so I can see it a little bit better. I mean, it looks something like this when it comes out of TF echo from the command line. I put it into a CSV file, which you're correct, Jeff. I didn't have to call it a CSV file. But it looks like this in the raw data. So I added some other fields here to make it look like a better pivot table. And if I put the frame ID in here as a heading, so you can split it out, I can see that some of the data, like this is the X data that we were looking at, you pointed out correctly that sometimes it's 0.421, and then it switches to this other number, a negative, really small number. But there's also some X's in here, down here. And these you can split out based on the frame ID. So they're slightly different. But under the map frame ID, there's really no unique way to split out where is this data coming from? Why are these 3 data points the same? And then why does it switch to this other data point? So I can't tell. So I've been combing through the code. I can't tell where these 2 different data points. I'm assuming this is all coming from the same node. So if I go back over here, I'm assuming one of these nodes, I don't know which one, but one of those nodes is publishing this set of data, and then a different node is publishing this point. And the theory is one of these 2 is wrong. They can't both be correct.
Well, my thought is your odometry node is publishing a map to ODOM transform, and AMCL is also publishing a map to ODOM transform. So what you need to do, you need to go into your odometry node and turn off its publishing of a map to ODOM transform.
Yeah, I think
The way transform works, you've got a point to point. So you've got one thing that's saying, I want to create a transform between this point and this point. And transform, when it subscribes to things, it can listen to 100 different things and expects each one of those to tell it what you're trying to create. So it expects only one thing to be generating a map to ODOM transform, and say an ODOM to baselink transform, and say a baselink to robot footprint transform. So you can't have two different things both creating a transform, because then it just switches back and forth between those, because it's expecting each one of those to be unique. And I know for a fact, if you follow the odometry examples they show you, they publish an odometry topic and they publish an odometry transform. But if you're running an AMCL, it wants to publish a map to ODOM transform. So you have to go back into your odometry and turn that one off, so you don't have two things both published at the same time.
So if we go down that path, which I think is probably good, right? If I go into the code, and I don't think this is necessarily, let me look at which, this is an odometry script, but I don't necessarily know if this is the right place. So I'm looking for, like here I have a publisher. This is publishing on ODOM. So I'm looking for a publisher that's publishing to TF, right?
Well, it says self.tf.broadcaster. I assume that is publishing the thing you're seeing right now.
This one right here.
So whichever line there, I can just barely read what you've got there.
Yeah, row
somewhere
42.
It'll say publish. So the odometry node is going to do two things. It's going to publish an odometry topic, and it's going to publish an odometry transform. And right there is probably where it says TF broadcaster. That probably is publishing the odometry transform. So that line, that second line.
That? Maybe that's up here. Let me open this up.
I think that line just had selected is probably what's actually doing the publishing. So the second line is highlighted there. It says self TF broadcaster equals TF transform broadcaster. That's probably, I don't know that much about Python, but I'm guessing that's what's publishing it. And then starting with the next line, it's actually publishing the topic down below.
So if I want to dig into this, how do I dig into where is this? It seems to be, it's like it should be one of these imports, although I'm not seeing it.
Well, I don't know you need to dig into anything. You just need to comment out that line that's publishing the transform. And that'll prevent it from doing that. If you wanted to, you can go in, you can say, read a parameter that says, do we want to publish a transform true or false? And then down here at this line, you'd say, if it says publish the transform true, then you'd go ahead and execute the line. If it says false, then don't execute the line.
Yeah. So there's really, I mean, I can do that, right? I can go try that. But there's really like these others. So let's take a different one. If I want to find where this one's coming from, this robot state publisher, how would I go about finding that in the code? I'm assuming it's up under my melodic installation up here.
Well, I believe what robot state publisher is, that's the separate node that's running. It goes out to a URDF file and says, oh, here's 5 different things I've defined. It pulls off the transforms for those and publishes each one separately. So that particular one there that says robot state publisher might be publishing several things. It might have a base link to laser scanner, it might have a base link to GPS, it might have, there might be several things that's publishing. So what you're showing right now, it's hard to know what's actually happening there. Because even the other ones you have, the stuff in the background there where it says EKF localization is publishing 2 different things, there's really no way to know what those are publishing. So I think there's something else you could look at to find that out. Maybe if you look at either your transform tree, where you say I can't remember what the command is. You run this command for, it says runs for 5 seconds and pulls up brings up a tree of your transforms. That's one thing you can look at. There's got to be something that tells you what the source and destination of all these different things is, I would think.
Yeah, that's what I was hoping to find.
And also, if you're running RViz, go in and say, go over to the left where it says, show me transforms, and then down under that it'll say, show me the tree, and you can as you go down under RViz, you should be able to see, it'll tell you the different things. You've got two different things that are talking to the same, at the same level as your transform tree. That is probably a clue as to what's going on.
Yeah, this gives the same. So I've got the node name here. What it doesn't tell me, and this is the struggle I'm having right now, is trying to figure out, so which file, which part of the code does this come from? Any one of these, where do they come from, and how do you find that?
Well, any node you have running that wants to create a transform link, say on this picture you got right there between map and ODOM, what does that say? It says broadcaster EKF localization map. So apparently a node called EKF localization map is producing that link between map and ODOM. But I don't see ACM AMCL on here at all, which I expect that to be generating a transform between map and ODOM also.
Alan, are you looking for the code that corresponds to that node?
Right.
Do you know Ross? Oh geez, Ross node info. What is it? I usually type it and I don't think about it.
Right. So if I go to Ross node info and then rover robot, oops, yeah, bot state publisher. It'll list, so it'll list the node again at the top here, and then publications. It'll just list the topic name and the message type. So it's the TF2 underscore messages / TF message is the message type, and then it'll tell you the topic / TF. And it could go down further here. It does give the different IP addresses with ports, but it doesn't really say, go look in this Python file or this C++ file to find out, you know, where that came from, where that node was created in the code.
Let's see, if you do a Ross CD to that directory, let's see. No, what is it? There's a better way to do it. Oh, Ross. What is it? Rosscat? If you Rosscat the name of the node, does that give it to you? I haven't done this.
Well, I don't think you can Rosscat the topic. Right?
No,
You'd have to
not the
Rosscat
topic, the node name. Or Ross Ed? I've never used Ross Ed. I don't even know what it is. Is it edit?
We'll see, huh?
Let's just type random commands today and see what happens.
I mean, I think, what's bringing up all these nodes? Do you have a launch script that's launching all these nodes?
Hey, Ross Ed does let you directly edit a file, by the way. That's cool.
Okay, so the question about, can you see this? Is that Walter that was asking that?
Yeah, I'm driving, so I'm just gonna have to trust you.
Yeah, let these guys try to interpret here. So I have two launch files. The first file that I launch launches Gazebo, So it's called move base controller.launch. Yeah, and it's not super long. It's about 40 lines of code. And it also kicks off some other launch files. And if I go down here, there is a robot state publisher that it kicks off. And it talks about converting joint states to TF transforms for RViz, etc. And it has a remap from joint states to joint states.
So what that's doing, it's going into your URDF file where you've defined the model of your robot, and you say, here's a GPS, here's a laser scanner, here's a wheel, here's another wheel. It goes through and strips all that information off and creates a transform for each one of those objects that's in there. So it's basically creating a static transform for each one of those. So rather than you having to go into a launch file and saying, create a static transform between baselink and GPS, create a static transform between baselink and laser scanner, it just pulls all the stuff out of your URDF file and generates those for you. So if you go to the URDF file, you could find each one of those objects in there, and each one of those will generate a transform for you.
Right.
So that's one thing that's generating transforms. Do you have RViz running at this point?
Yeah, I do. Yep.
So go over on the left there where it says TF and open that up. And then under that, yeah, look under both tree and frames and see what you have under there. So then on the under frames, maybe tree. Look under tree. You got map. You got ODOM. What do you got under ODOM? Chassis footprint. So I was thinking there it should tell you between. Well, it only shows it shows map connected to ODOM and ODOM connected to chassis footprint. I expected to see another thing in there talking to ODOM. So up above there where it says either under map or under ODOM, do those have anything extra? If you pull those down. So there it says parent, and so each transform is going to have a parent and a child to it. And then let's see, under map, it has no parent because it's the top level.
Right.
And then under ODOM, it says the parent is map. So it says those two are connected together. So I expected something else to be generating say a map to ODOM or something to ODOM transform. And just looking at the list you have there, it's not jumping out at me what it would be. And transforms are different than topics, even though apparently, after looking at all this, apparently it's published over topics, but it's creating something. It's a totally separate system that's going on. It's saying this is where 2 points are located in the system, and it's building a link between those, and then it builds this transform tree to connect everything together.
And it builds it at a time. Keep that in mind. Everything screws up if you get your times off.
It's an iterative process, though, isn't it? So like in real time, it keeps generating the transform, or is it just
Right,
generated once?
You can go back and look for a transform at a given time.
Oh, okay.
Which turns out to be really cool, but it can cause some real problems. You'll get some errors that you're trying to extrapolate into the future or something. Or I do.
Just to step back just a second here, I'll show you. Here's part of the fun that I'm trying to work through, right? So I stopped it. Well, I can, here's Gazebo. And if I run it in Gazebo, let it run, it's very smooth. It seems to know where it is located in between these plants driving down the row. Seems pretty good. But if I move Gazebo off to the other screen and then run it and watch it in RViz, let me give it a new goal up here. You see how it kind of jumps around a little bit? So that's one problem, is it's jumping back and forth.
It could
and then the other. The other
If you
issue
turn on
is this point right here. This is the ground truth. If I go down here to ground truth odometry, coming off the ground truth topic, that's this arrow right here, which isn't, I've got this disconnect between the actual image and the ground truth. But then if I compare it to gazebo, it's a little hard to tell exactly here if I can fit it all on the screen. But it actually looks like this picture of the rover is actually is very close to what it looks like in gazebo. It almost looks like ground truth is too far. It's not actually where ground truth is. So those are the two main things I'm trying to work through and figure out at this point.
Also, if you turn on the visibility for the TF and then looking at RViz, you can zoom in on it and see what the markers are doing when you do that. So on your left there under TF, turn on the checkbox for that so you can see it.
Oh, got you, like this?
And now go zoom in on your RViz over there. See down at the bottom, you've got one of them's probably ODOM and one's probably MAP.
Oops, yeah, right here.
And as you drive around, what happens is if you're running AMCL will start dragging that ODOM marker around to correct for where it thinks you are. Now it could be that difference between MAP and ODOM is the difference between your ground truth and something else. But you can see that ODOM markers is kind of wiggling around as you drive around. That's not moving a lot, I guess, but
I don't understand why it's shifting back and forth like that.
That's his original question of why it's doing that.
Yeah, but it's not even, what's the
And my thought was that ODOM's publishing a transform and AMCL's publishing a transform. And
Yep.
are you still running AMCL at this point?
Right, yeah, I haven't taken that out yet.
So I think
Yeah, I think you're right, Jeff.
You have two different nodes publishing a transform at the same time, and it just keeps switching back and forth between the two. And
Right.
as far as figuring out what's actually publishing that, I'm not completely sure.
I think to prove that,
you could turn off everything else. You got lots of stuff running right now. If you turn off almost everything till you just got the robot and see what's happening at that point, you might be better off.
And what are the chances, with the ROS launch, could you, in that sense, turn things off to stop, to find out, like eliminate one by one maybe, or I don't know if that's possible with as many things as you're launching. I don't know for sure.
Does everyone know how to use ROSMON?
I don't.
No.
You should all be using ROSMON. It makes stuff like this trivial. Instead of using ROS launch, just do ROS run, ROSMON, and then whatever you were going to ROS launch. Make sure that you have ROSMON installed.
So install that first. Okay.
And then you can turn things on and off willy-nilly.
Oh yeah, that's awesome.
Yeah, it helps when you screw things up as much as I do.
Another idea in seeing if Jeff's theory is correct is, can you pull up your RQT TF tree again?
Sure, let's see.
And I'll just put this in the queue. I'd like to see a TF echo.
He had the TF echo in a CSV that he showed us earlier, right?
Does it jump around?
In position, it jumps around, yeah. Okay.
Oh. Sorry, I was out for a while.
We'll
So-
go back to that in a second here. So this is what you're looking for first, Vinny?
Yeah, and then go ahead and hit refresh. And let's try to keep an eye on the broadcaster and see if that changes.
Oh, here we go. So I caught it.
Yeah,
Yeah, I've done this before where if you refresh enough times, eventually like here, there, now it's broadcast to AMCL.
yeah.
Boing.
So Jeff is correct. There are two different broadcasters and you should turn one of them off.
And so you think the easiest way to do that is to go into, I think we're right here. Just go in and comment out this line, one or both of these lines.
I don't know. I was gonna suggest just don't launch AMCL. So wherever you launch up AMCL or robot localization or whatever.
I think it's probably here.
That one, right?
Don't launch that one.
Yeah.
Okay, and that's probably all of these parameters are all associated with that. So all the way down to here probably.
Right.
It'll be so much easier for you to just run Rossmon.
Okay. Yeah, and
I'm
then,
really an advocate for it.
okay, yeah, that sounds good. And then to see, this is the TF Echo data. I put it into a pivot table so you can see it, but this is the, just taking the X coordinate from the map frame ID. Here's where it jumps to the other number, and then it jumps back up again and down again.
I think you're going to solve this.
So back to the other good diagram you just had where you said if you watch long enough, you can see the two different publishers. What were the two publishers? One was AMCL, what was the other one? You had that graph up.
This one here,
Yeah.
yeah, AMCL and EKF localization map.
So neither one of those are ODOM, so it could be that it's coming from somewhere else.
Well, that's why I was suggesting to attack AMCL first.
Yeah.
So that was this one. So that's another option to look at. Okay.
And it could be running enough times that ODOM is also publishing another conflicting version of that too. So just something to keep in mind. Now, there's got to be a way, there's got to be a command you'll type in and says, this is where, these are all the things that are creating that transform, but I don't know what the command is to do that.
All right. Well, good insights for tonight for me.
That's really cool, Alan. Maybe if you want to just do a quick test in that EKF map node, in the YAML file, there's just one line that says, do you want to publish the transforms? So if you turn that off, then you'll just be on AMCL. Or Rossmon, you can turn on and off whatever nodes you want.
Oh, sorry. Let me go back here. Okay. So say that again now in the.
Well, if you just want to do just a quick test, if you have two broadcasters inside of the EKF, it looks like
Maybe
one
this
transform, yeah, and then there's one line that says broadcast transform, and then you could just set that to false, just as a quick test.
Yes, I remember seeing that broadcast transform. Maybe it's this one.
Maybe it's something transform. Maybe it's not broadcast, but or publish transform.
But the moral of the story is you only want one thing creating the transform between point A and point B. So if you have
Yes.
multiple things doing it, you have to turn off all the other ones except the one that you want.
I wonder if Ross WTF would have caught this.
Possibly. I thought
be
about
funny.
bringing it up, and I can't remember what that does. Can't remember what it tells you.
Well,
I would
it
think.
does, yeah.
I would think if you looked at TF Monitor for a while, it would show multiple broadcasters.
It's all one word. Yep.
Yeah, it does give me two things down here at the bottom.
Yep, that bottom one is what you want.
The bottom one, I think, is the one Jeff's been talking about, right?
Yeah.
Yep. It did tell you. Look at that. How easy that was.
So the hard part, though, I guess, I mean, I can kind of see where we're going here. The sort of workaround, we're doing a workaround instead of getting to the root problem. If I just turn it off, right, then I'll know if that's the problem, right? I'll kind of fix it by taking that component completely out. But I want to ultimately add that component back in again. And so I'm kind of still stuck as to how I'm going to really get to a root cause fix.
Alan, I think you are addressing the root cause, because I don't see a reason that you need both the EKF and the AMCL running at the same time. They're doing different things, aren't they?
Oh, you think
Or they're doing the same things, aren't they?
you think they're doing the same thing?
Well, I
In
believe
different
what's-
methods, but yeah, go ahead.
I believe what's happening is that since you have two versions of EKF running, two versions of robot localization, they take the odometry and the IMU and they merge those together to give them an odometry, and then you take your GPS and that original odometry and feed them into the second
Right.
EKF, and then that.
Right.
So basically, the AMCL goes in with that first set of things you're doing. So I think if you go back to the robot localization tutorials, they're going to tell you turn this on, turn this off, and they say this is what should be creating the transforms. And I was thinking that what's it, Clearpath Robotics has a tutorial. I think they're the one that support robot localization now. I think they've got a tutorial and they'll tell you how to connect that stuff together and tell you what should be creating transforms when. So I think if you read through that, it might give you a good idea what you should be doing.
Yeah, I think you're right, Jeff. Roughly the way you described it, right? There's something to do with the IMU data, the ODOM data coming off the wheels, the GPS data, and then there's two laser sensors on there. So fusing all of that together is part of the EKF nodes. And then, you know, I guess to Vinny's point, then I think what you're saying is after all that work is done on the EKF side, then the AMCL is duplicating some of that work. And so if I just turn one of those off, probably turn the AMCL off, I'm not going to lose anything, I think is what you're saying.
Yeah, without knowing your architecture better, I don't think you're going to lose anything.
Okay. Well, that's very helpful because I can now see how I can turn those off. So that's a big step in the right direction.
I think if you go back through that tutorial, they'll tell you step by step, you know, how you feed this stuff in, why you need this, why you don't need that. So on each one of the EKF filters, you can turn the different things on and off that are coming into it. And I think the way the original stuff where you're not running robot localization, they take the odometry and the IMU and AMCL and merge that all together without using any EKF. So now if you're taking that and feed that into the robot localization as one step, that gives you the corrected odometry. And then you've got a second EKF that takes the corrected odometry and the GPS and merges those together. So in all these multiple steps, on each one of those, you can configure and turn things on and off. So you just have to figure out, you know, what you want to happen at each step. And I think the tutorial tells you basically how to do that. Although I can't
Very
say I've
nice.
ever done that completely, but I think that's the approach to that.
Got it. Okay. Yeah, and I think you had put that link out there in Slack before, so.
If you are fusing your AMCL data in the EKF, then you don't want the AMCL node to publish the TF because it doesn't have the accurate information. You're assuming that the EKF is going to have the accurate information. But if you're not using the EKF, then you want the AMCL to publish. It's kind of how that works.
So related to that, there possibly is a parameter on AMCL that says publish transform yes or no. So there might be a
Yep.
way, just by changing that parameter, you can get that to turn on and off. And it could even be there's an extra parameter that's not showing up in your list right there. You know, they just put in what they wanted to change at that point. And it could be if you go look at the documentation for, say, AMCL, it'll say, here's some extra parameters you're not using. So there may be something else you could put in there too.
I think, Matt, earlier you were talking about broadcast something or other. Here's broadcast UTM transform. But I think you were saying something else.
Well, if you're fusing the data from the AMCL, then the EKF becomes your real position. And so that we use that one to transform or to broadcast. Yeah, there is, it's called in AMCL, it's called TF broadcast, and it's a Boolean set to true by default. So you'll just need to set that to false because you're basically sending the AMCL data to the EKF, and now it becomes the authority for your position. And like Jeff said, sometimes in the launch file, they don't have all of the parameters there, but on the wiki, it's just called TF broadcast.
Okay.
TF underscore broadcast is the parameter name.
And then what does it have? A colon true?
I would need to look that up. It could be value. If it's a Boolean, if it's a type Boolean, it would be value equal 1 or 0. I quote 1 or 0, but.
Isn't another way to look at this, you know, launching everything and then looking at your ROS param list?
Yeah, that would show you if you are setting that. Well, by default, it's going to publish it. So
then you can use dynamic reconfigure to set it to false, just as a band-aid. But yeah, I agree that in the launch file, you should explicitly set it to false. Well, yeah, what I'm saying is you probably won't find it by searching it in your project path.
This was pretty cool. So you can see the package graph. That was fun. Okay, so you're saying go here and go to somewhere in here.
Yep, it's right there, TF broadcast.
Right here.
Yep.
Oh, look at that. Matt's still recording so we can remember this later. Okay.
Yep. So this.
But
is
just
what
to be
you'll-
clear, this is a Band-Aid, but put it in your launch file next time.
So I posted in the chat what you want to put in your AMCL launch. It's looking good, Alan. It's pretty cool.
It doesn't seem like it's jumping right now, but let's get it turned around here first and see.
If you have an offset between your ground truth and your vehicle, it's probably somewhere in your gazebo model. You've got an offset put in there.
You know, it
It's really
seems
cool.
like the delta gets bigger the further I am away from 0, 0. I'm not sure that's always the case, but it seems like it gets bigger this way, and then if I go back the other way, it's bigger going the other way. So it's somewhat proportional to the distance, and I'm wondering if that's because as the wheels are turning, they're turning 1 revolution, let's say, and it's thinking it's only turning 0.8 revolutions or something like that. There's some kind of a mismatch. So it thinks from the wheel's position perspective that it's only gone this far, but it's really gone this far. Could that be something like that?
Yeah, like on your EKF, what it does is it looks at your error measurements from your sensors, your covariance. And so if one sensor happens to be very large and it's more accurate, and your wheel encoders, for example, are perfect and they're not accurate, it will weight those measurements more. So you want to take a look at each one of your sensors. Like you can see that dot, you have the covariance turned on, and that's kind of like your position estimate there, that purple circle.
Mm-hmm. Right, this one here.
And that's pretty large. But
Okay.
you'll want to take a, but like, let's say hypothetically, like you were saying, the wheel encoders are perfect. And then it would be fusing that big error or that big error estimate with a very small error estimate, and it would weight it would weight an incorrect value more. It gets a little tricky.
Yeah.
Or you simply have a wrong wheel diameter entered in somewhere. So gazebo thinks it's one thing and your other code thinks it's something else. That might be another reason why that would
That was
be
my
a
thought,
problem.
yeah. And we, I think the other thing, ultimately, what should happen is I think GPS is going to be very accurate. So most of the time, I think I want the GPS to have the strongest weighting, except for those times when it drops out of fixed into float. And then when it drops into float, then I want to rely on the wheel positions because the wheels, they're not turning, it's not going anywhere, so it's exactly where it left off. If they're going straight ahead or at an angle or whatever, steering, I should be able to tell where it's going for a little while, but then as the wheels start to slip, I'm going to get into less accuracy of knowing where I'm at until the GPS comes back. And once it comes back, then I should know exactly where I'm at again. And then the two lasers are just to keep it from running into something. So if there's some new object that shows up that wasn't there before, that's what they're for. They're maybe less about knowing where I'm at, but more for obstacle avoidance. All right, well, turn that off. That's good input.
Good job. That's really cool. Love it. Anything else for tonight's meeting? All right. Guys, have a great week.
Thanks, everyone.
All
See
right,
y'all.
thanks
Thanks, man.
everybody.
Mhm.